In this tutorial, I'm going to show you how to use the new surface modeling tools. These are available in VRGS 3.2 build 27. I've already got a model loaded and I've done an interpretation on the outcrop using the polyline tool. What we're going to do is extend this interpretation into and out of the outcrop, or in front and behind the outcrop, using the orthopanel tool. I've already put in a structural measurement below this channel unit. I'm going to use this as a way of orienting our orthopanel. So I'm going to select orthopanel. The default orthopanel mode will create an orthopanel based on the orientation of a structural measurement. There's our orthopanel has been generated there. I'm going to change the dimensions. So I'm going to make it 150 meters wide and 30 meters high. To move the orthopanel, select 3D Translate from the Interpretations menu, click on the orthopanel, and then you get the translation tool. And that allows you to move the orthopanel in different directions. Right, so there is our first ortho panel, and we can see the position of the interpretation. I've set this panel to be looking down the dip, but what we really want to be able to do is rotate this panel so that it is taking account the structural dip, but also looking along the paleocurrent direction. I know the paleocurrents here are going more or less north-south. I can then add that rotation in to the orthopanel properties. So I'm going to set this to 170. And there it's changed the orientation of the orthopanel, so it's now taking into account both the structural dip and the paleocurrent direction. So we go back to 3D Translate. And we'll move this over here like this. And then we're going to use this orthopanel as a guide to show more or less where the channel is going to be. So I'll just follow the existing interpretation. Do the same thing again, 3D Translate. Take the orthopanel to the other side, just drop it down and use the same process. Digitize polyline, and we're going to put in a approximate position for that surface. So we've projected that surface in front of and behind the outcrop, and we've got our original interpretations. They will have all gone into here. So these are the interpretations that I first created. So let's zoom in on those. And these are the ones that I've just generated. So let's just then group these. And now to do the surface generation, I'm going to right click and go to convert to radius. So our first surface has been generated. Go to your data tab. We'll find a new mesh has been generated. We can look at the properties in here. So we have our grid spacing, smoothing if we want it, and then the properties of the variogram that's been used to generate this grid. We can experiment with those, but for most cases, VRGS will pull out a reasonable set of value for them. The ones that you might want to change is the lengths of the axes. Let's switch the contours on, and then we get a better feel for the geometry of the surface and how we might want to edit it. We might want to change what's going on over here where we are away from the outcrop. There's a set of editing tools in here now. Draw contour. The first thing I'm going to do is go back to my interpretations here, select the folder that our interpretations for this surface are in, and go set focus. That means whenever I create a new polyline, it will go straight into this folder. Now, the draw contour tool takes the Z value from the first position that you click on the surface. That first position isn't used. It just sets the Z value. So now we can go over here and I'm going to start and digitize in a new contour. Double click to finish. And then you see it's automatically updated the surface with that new contour value. And the first point that I clicked that was just here isn't included in that polyline, just used to set the Z value. If we switch off our ortho panel and the mesh as well, or the outcrop model, then we get a better feel for what's going on with the contours. In this next example, we're going to build this fault. We'll start with the same process, digitize polyline, and I shall digitize in the trace of the fault. You can see there's already a structural measurement in there, so we'll finish that there. And let's put in another polyline along here. So we think the fault is coming out along the shore just there. So those two polylines together are going to represent our fault. So we do a group in the interpretations tree and then convert to regular grid. This gives us a surface that doesn't really look like what we want, because this is quite a steep surface. The gridding algorithms don't always give such good results unless you've got quite a lot of information, which we don't really have here. But what we can do is take an orientation. As I said, I already have one, but let's just quickly go in. Let's switch off the grid, and all we would do, switch off our polylines. I've got one there, but I'll add another one in. Dip azimuth, 1, 2, 3 points along the fault, and we've got an orientation. So I'm going to select that orientation I've just done, do copy orientation. Let's go back to our grid. Right click, surface generator. This menu only appears when you're using the gridding algorithms. Paste orientation. And what we have to remember to do is switch the polylines back on, because it's whether it uses the polylines or not depends on whether they're displayed. So they have to be within the group that you did the convert to regular grid from, but also have to be switched on. So let's do that again. I could just do surface generator, paste orientation again, or I could have done a regenerate. And there's our new surface that is taking into account the structural dip and the polylines. Well, the next thing we can do is use a similar approach to what we did before. So let's switch off our polylines, and I'm going to use an ortho panel based on one of those orientations. There it is. We're going to switch it to be an ortho panel parallel to the dip direction. Let's change the width to 80, and let's change the height to 20. That might be a little bit better. 3D translate, and use our translator to move it out. Let's move our display around a bit. I might want to make my height a bit higher. There we go, that's better. And at this point, we probably want to switch off auto update on the ortho panel. And what that does is now when I move the ortho panel, it doesn't redraw it. It just takes that image, and then we can go over here and say, okay, well, I'm going to use this as a template to give me an idea of what this fault would look like over here. And we can use the ortho panel to draw another polyline. So I'm not going to worry too much about matching it exactly, because obviously by the time we're over here, the fault geometry is likely to have changed. It's not going to be exactly the same, but let's use it as a guide. So let me switch on the grid, and then I drop that into here. Now you see it's automatically updated the grid to match that new polyline. Just switch off the ortho panel, and on our grid we can show the contours and use those with our contouring tool if we need to. So that's a very easy way to build surfaces within VRGS.